Okay, ladies and gentlemen, let's take a look at this problem, number 36. Well, again, we have two fractions. Oh, son of a gun. Remember the last one? That was fun. So here we go. Probably two fractions means common denominators. Yay, common denominators. So if I have cosecant x plus 1, cosecant x minus 1, cosecant x plus 1 here, cosecant x plus 1 here. Over here, I need a cosecant x minus 1 and a cosecant x minus 1. Okay, so the nice thing is I got a twofer times a twofer on the bottom. FOIL, first times first, outer times outer, inner times inner, last times last. The whole thing is going to be over cosecant squared x minus 1. Hey, that looks familiar, but don't get ahead of yourselves. Let's go to the top. Let's give, I have a 1 times a twofer, so I got to FOIL it out. Sine x cosecant x minus sine x plus sine x cosecant x plus 1. Okay, with that, we're ready to go. And all we have is we have given, we have FOIL, nope, actually, sorry, common denominators. I suppose if you FOIL, that would also be accurate because we did a lot of that. Now, in this case, take a look up at the top. You have sine and cosecant. What happens to sine and cosecant? Well, they're reciprocals of one another. So that's going to turn into 1. And that's going to turn into 1. And so, uh-oh, I have a problem. I'm sure some of you have already seen it. Sine times cosecant is sine cosecant. Sine times sine is sine x. So I'm left with 1 minus sine x plus 1 plus sine x all over cosecant squared x minus 1. And so this is by reciprocal property. Now, what is negative sign and positive sign? They're gone. 1 plus 1 is 2. Now, on the bottom, we have cosecant squared x minus 1. Well, again, I had, let's see here. This would be cotangent squared x plus 1 is cosecant squared. I subtract 1 across, and that gives me cotangent squared. So cotangent squared x plus 1 equals cosecant squared x. That's the Pythagorean theorem. If I simply subtract 1 from both sides, I'm good to go. That gives me cotangent squared x on the bottom. So I have 2 over cotangent squared x by Pythagorean theorem, and simplify. And so cotangent on the bottom can move up top and say 2 tan squared x, and that was by reciprocal. Okay, there it is. There's 36. Now, with that, let's go to the next one. Let's go to 39. 39 says cosecant x over 1 minus sine x. And it says rewrite as an expression that does not involve a fractions. So we're looking at no fractions. That's our homework. Well, unfortunately, I have this, and it is definitely a fraction. I can't really split it up because the minus is in the bottom. If the minus were on the top, it'd actually be fairly easy. If I had 1 minus, I don't know, cosine x over tan x, if that's what it was, I would simply say, oh, that's 1 over tan x minus cosine x over tan x. And I would say, oh, well, that's easy because 1 over tan x is cotan x. And that would be minus, and that would be cosine x times cotangent x. And now I have no fractions, and nice day. Okay, but that's not what I have. I have a minus in the bottom. Now, if we go back to this problem, I have a cosecant x minus 1. Now, here I found common denominators. But a really common trick is if I can get some sort of Pythagorean theorem, which a Pythagorean theorem so often is 1 minus something squared. And if I could get that, that would help me out a bunch. So how do I turn this into 1 minus something squared? Well, if I said 1 minus sine x in both cases, that's okay. That's like finding common denominators. That's like saying 1/3 and saying 3 over 3. That's 3/9. It's the exact same thing. Okay, but in this case, when I FOILed it, I would get a 1 minus 2 sine x minus or plus sine squared. Yuck, that's awful. I don't like that. So that would give a middle term. What if I said 1 plus sine squared x? Ooh, 1 plus, that's helpful. Because now I have cosecant x times 1 plus sine x on top. I'm just going to leave that there for a minute. And here I get 1 minus, because of the minus and the plus, I get 1 minus sine squared x. Well, that looks like it should be really familiar. What is 1 minus sine squared x? Oh, so in this case, we would say given. Here we would say, really, that's called a conjugate. But if you said denominator or like fraction, that'd be fine too. 1 minus sine squared is cosine squared x. Cosecant x and 1 plus sine x. Now, in this case, we use the Pythagorean theorem. And by using the Pythagorean theorem, now I can take this and move it up top and call that secant squared x, cosecant x, parentheses 1 plus sine x. And that was by reciprocal. And now I have no fractions, and technically I'm done. I don't like it because it's ugly. There's a whole bunch of nastiness in there. But I could eliminate some of the nasty by doing this, give that away, and I say secant squared x times cosecant x plus cosecant x sine x. Well, wait a minute, cosecant x sine x cancels, makes 1, so I have secant squared x times cosecant x plus 1. You say, well, Mr. Moore, that's not really better. Well, I don't know, maybe it's a little better, but that's about as good as I can do. But the directions say rewrite as an expression that does not involve a fraction. By using the conjugate, which is the same two terms with the opposite sign in the middle, we can get rid of that fraction by using conjugate and a Pythagorean theorem. Very common, happens kind of a lot. Let's go one more. Let's go 3 tan x over 1 minus cosine x. This is for 42. Again, I'm going to go conjugate, 1 plus cosine x, 1 plus cosine x. So that was given. And I have 3 tan x, 1 plus cosine x, all over 1 minus cosine squared x. And that is by conjugate. And in this case, 1 minus cosine squared 3 tan x, parentheses 1 plus cosine x over sine squared x. And so that's by Pythagorean theorem. And so then this can go up top as a cosecant squared x, 3 times tan x times 1 plus cosine x. And that is by reciprocal. And that is nasty, but there are no fractions in it, so it is a win.